Hello everyone, welcome back to another video of our multi-threading in Java series. And in this video, we will be looking into the constructor internals of executor service. Now, if you see the code for initialization of different types of thread pools, you will notice that they are very simple. We use new fixed thread pool, new cached thread pool, new scheduled thread pool, new single thread executor, and new work stealing pool. Correct? Now, if you go into the internals of each of these simple functions, you will notice that internally they all use the same constructor of ThreadPoolExecutor. If you go inside further, you will see that this is the main constructor which is being used to create thread pool. This constructor takes 7 parameters except for the work stealing pool. This work stealing pool uses a separate type of class which is fork join pool. Correct? So first, let's understand 7 parameters and what is the value of each of them in different types of thread pools, except the work stealing pool. Work stealing pool we will cover separately as it uses different underlying class and work stealing algorithm. Right? So we have ThreadPoolExecutor class. These are the 7 parameters that ThreadPoolExecutor class has. And now, let's start with the 2 parameters that define the scale of the thread army, core pool size and maximum pool size. So core pool size is the base number of threads the pool tries to maintain. Threads in the core pool will not be terminated even when they are idle. So think of them as your permanent staff. They are always ready to take a task. Now, maximum pool size is the absolute upper limit of threads the pool can create. The pool only creates the thread above the core pool size when the work queue is full and all the threads in core pool size are busy. So this parameter controls resource protection so that you don't overwhelm your CPU by spawning infinite number of threads. Next is KeepAliveTime and time unit. KeepAliveTime specifies the time that excessive threads are the threads which are created above the core pool size threads, right? So KeepAliveTime specifies the time that excessive threads will wait for a new task before they are terminated and removed from the pool. Correct? So it's a way of shrinking back down to the core pool size during periods of low activity. Now let's see what are the values of these constructor parameters in different types of thread pools. So for fixed thread pool, the core pool size and max pool size is equal, and it is equal to whatever value the user passes in the constructor. Now since both core pool size and max pool size are equal, there will be no excessive threads created, right? And since there are no excessive threads created, there will be no termination of threads. And since there is no termination of threads, that is why keep alive time is 0. Now this 0 here can be misleading, but it means keep alive time is ignored or is not applicable for fixed thread pool, because keep alive time is only applicable for destroying excessive threads, and since there are no excessive threads, therefore keep alive time is ignored in case of fixed thread pool. Similar is the case for single thread executor. In single thread executor also, core pool size and max pool size are equal, and that is equal to 1, and here as well keep alive time is ignored. Correct? For cached thread pool, the core pool size is 0 and max pool size can go up to the maximum value of integer, and keep alive time is 60 seconds. That means if a thread is idle for 60 seconds, then it will be terminated, right? Excessive threads. And now core pool size is 0 because threads are created dynamically as the task arrive, and if there are no tasks, there is a possibility that all the threads will be terminated. Correct? That is why core pool size is 0 for cached thread pool. Correct? For scheduled thread pool, the core pool size is whatever size the user passes, and again the max pool size can go up to the max value of integer. And here the default implementation in Java has keep alive time as 10 milliseconds. Now you don't need to memorize this. These are intuitive if you know how exactly these pools work, which I have already explained in my last video, and I will link the video here as well. Now the next parameter is the work queue, which is of type blocking queue, and it takes a runnable. The work queue is perhaps the most important parameter. It dictates the behavior when the threads in the core pool are busy. So basically a task comes in, the core pool is full, so the task goes here in the work queue. Now the choice of work queue, or you can say blocking queue, determines the pool's entire scheduling strategy. And there are 4 main types of blocking queue. The first type of blocking queue is linked blocking queue. Now this queue is unbounded, which means it has virtually infinite capacity. It uses linked list internally, which explains why it has infinite capacity, because linked list can have infinite number of nodes. If you use this queue, the task will keep piling up in the queue until the queue gets full. Now since the queue's capacity is infinite, therefore it never gets full, correct? Now if you see fixed thread pool and single thread executor, here the core pool size is equal to the max pool size. Therefore the number of threads created are fixed and bounded by the core pool size, correct? Now if the number of threads are fixed and all are busy, you will need a queue where you can store extra infinite number of tasks that keep on coming, correct? So that when the thread gets free, they pick up the task from the queue and execute them, making sure no tasks are lost, right? So if the number of threads are bounded, the queue needs to be unbounded to store tasks, correct? Therefore, we use linked blocking queue, basically a queue with infinite capacity for fixed thread pool and single thread executor, because there the number of threads in core pool size are limited. Those are bounded, correct? So the threads are bounded, therefore we use the type of queue which is unbounded. Now second type is synchronous queue or zero capacity queue. Now this queue has zero capacity. So it only accepts a task if a thread is waiting and ready to execute it immediately. Why? Because the capacity of queue is zero. It cannot keep a task with itself. As soon as the task arrives, it will only keep that task if a thread is waiting or a new thread is created immediately to execute it. Right? So if there are no waiting threads, the pool must create a new thread to execute the task. Now since cached thread pool allows to quickly spawn a new thread for every new request, therefore synchronous queue is used in cached thread pool, correct? Now the third type of work queue is delayed work queue. Now this is a specialized queue that orders tasks based on their scheduled execution time. Therefore, this is used by scheduled ThreadPool executor. Now the fourth type of work queue is array blocking queue. Now it is a bounded queue and it has fixed size. So the default implementation of any of the pool does not use this, but you can use this as your custom implementation with fixed size and bounded size, correct? So array blocking queue is type of bounded queue. So if we conclude it, the fixed thread pool and single thread executor uses linked blocking queue, right? Cached thread pool uses synchronous queue and scheduled thread pool uses delayed work queue, correct? Now before moving to the next parameter, let's see the steps that occur irrespective of whichever pool you create and submit tasks. Whatever new task arrives, those tasks are first handled by the core threads which are present inside the core pool size, correct? Now if the core threads are busy, all the threads are busy, the tasks are then put into the queue put into the work queue until the limit of the work queue is exhausted, until the work queue is completely full. Now, if the queue becomes full, correct, and all the threads in the core pool size are busy, then the pool attempts to create excessive threads until the maximum pool size is reached, correct? Now, if the queue is full, the core pool size is full, you have created excessive threads as well till maximum pool size, right? Maximum pool size is also exhausted. Then the extra tasks that arrive for the task queue are handled by our next constructor parameter that is called the rejection handler, correct? So these are the steps summarized in this diagram, and finally if everything is full, then rejection handler comes into play, correct? So rejection handler handles the extra task, and this handling is governed by some standard policies. Now there are 4 different policies that rejection handler follows. Now the first policy is the abort policy. The abort policy basically throws a rejected execution exception. So a rejected execution exception is thrown whenever extra tasks arrive and all the threads are busy, right? So this is usually the best choice for debugging, as it tells you immediately that your pool is overloaded and it throws a rejected execution exception, correct? So you'll definitely know this is very safe and very good choice for debugging. Now the second type of policy is discard policy. So this policy silently discards the new incoming tasks, new incoming extra tasks, right? So it is considered as dangerous because your task vanishes without a trace and there is no notification generated for the task submitter, right? Therefore, this is considered dangerous. Now the third type of rejection policy is discard oldest rejection policy. Now here the oldest task in the work queue is discarded and new incoming task is submitted in the queue again, correct? Now this one is very interesting. The fourth type of rejection policy, which is called caller runs policy. Now here the thread that submitted the tasks executes the task itself. So basically what does it mean? So after the work queue is full and all the threads are full, the extra tasks which are being submitted to the thread pool is sent back to the submitter, which is generally, the submitter is generally the main thread, and the main thread itself is asked to execute the extra task that it has sent to the thread pool, correct? So what it does, this basically slows down the main application thread, providing a back pressure, which in turn slows down the task submission rate and gives some breathing space to the threads executing the tasks, correct? And this loop that we just saw is also known as feedback loop, correct? Now these were the 6 parameters till now. Now the 7th parameter, the last parameter, is the ThreadFactory parameter. Now this parameter is often overlooked, but it's very vital. So it's an object responsible for creating new threads for the pool. So if you ever had a nasty stack trace that just says pool 1, thread 1 or thread 15 or something like that, correct? So if you use this 7th parameter and pass in your custom thread factory for creating a thread, then it lets you set meaningful thread names like payment processor 1 or web processor thread 1, something like that, right? Meaningful name that you yourself can define. So it has meaningful name, which in turn makes your debugging much easier, as now by thread's name itself, you know in which layer the issue has occurred in your application. Here, the payment layer, your issue has occurred, correct? So at last, let's see the configuration of fork join pool. So fork join pool uses parallelism, and the number of threads that it creates is equal to the number of available processors, correct? The algorithm which fork join pool uses is the work stealing algorithm that we have seen in the last video. The task queue is D queue. Double-ended queue is used for each of the worker thread, facilitating the work stealing approach. And the use case where fork join pool is used is very high performance, heavy and parallel processing tasks, correct? Because it makes sure that all the cores of the CPU are always busy. So now you know that newFixedThreadPool is just a neat shortcut for a long, powerful constructor call that happens behind the scenes, correct? So understanding these 7 parameters gives you the power to create your own custom thread pool perfectly tailored to your application needs rather than relying on the 5 default values that are passed. So I hope you understood the constructor parameters. That's it for this video. Until the next video, stay safe, stay healthy. Bye bye.